This six-story structure is not a building. It is an engine, and it is so big that workers can walk around inside it. It powers a propeller as tall as a two-story house, and when it starts up for the first time, it drinks 100,000 liters of fuel just to get going. This is the story of how 9 of the largest eco-friendly ships ever built were constructed in just 2 years. Right now, as you watch this, 38,000 cargo ships are moving across the world's oceans every single day. That number is hard to picture, so think of it this way. 90% of everything you own, your phone, your clothes, the food in your kitchen, arrived by sea at some point. Shipping is the invisible engine of the entire global economy, and it has been for centuries. But here is the problem that nobody really talks about. The ships doing all of this work are running on some of the dirtiest fuel on Earth. Heavy fuel oil, the kind most cargo ships burn, produces massive amounts of sulfur dioxide, carbon particles, and greenhouse gases. One large cargo ship can produce as much air pollution as 50 million cars. The shipping industry as a whole is responsible for roughly 2.5% of global greenhouse gas emissions every year. A French shipping company called CMA-CGM decided they wanted to change that. Their goal was to build the largest eco-friendly container ship in the world, one that would run not on diesel or heavy fuel oil, but on LNG, liquefied natural gas. It is not a perfect solution, but compared to what ships have been burning for 100 years, it is a massive step forward. And they did not want to build just one of these ships. They wanted 9, all within 2 years. To understand what that means, you need to understand the scale of what they were trying to build. Each ship is 400 meters long. Line up 4 football pitches end to end, and you have the length of one ship. The width is 61 meters. The height from keel to top is taller than the Qutb Minar in Delhi. The total weight of each ship, without any cargo, is 70,000 tons, equivalent to 7 Eiffel Towers. Each ship can carry 23,000 shipping containers. If you place those containers end to end in a single line, they would stretch for 150 kilometers. And this thing needs to travel from Asia to Europe, one of the longest and most demanding shipping routes on Earth, without stopping to refuel. To build 9 of these ships in 2 years, a shipyard in Hong Kong was selected. The yard is 4 kilometers long and looks like a small city. At peak construction, 6,000 workers from around the world were working there around the clock, every single day, each one with a specific assigned task. The challenge was straightforward to describe and almost impossible to execute. Normally, it takes 18 months to build a single ship of this type. CMA-CGM needed 9 ships. The only way to make that timeline work was to build in parallel, to have multiple ships in different stages of construction simultaneously. The construction starts with steel. The foundation of a ship like this is steel plate. Each ship required 12,660 individual steel sheets. These sheets were cut using a laser beam operating at 18,000 degrees Celsius, 3 times hotter than the surface of the sun. That laser cuts through steel the way a hot knife cuts through butter, with a precision that hand tools could never achieve. For a single ship, the total length of steel strips cut during this process was 880 kilometers. Once cut, the sheets were welded into sections called blocks. These blocks range in size from a single room to a multi-story structure. The critical innovation in this process is that the blocks are not hollow shells. They arrive at the assembly site already fitted with pipes, wiring, and internal equipment. By the time a block is lifted into position on the ship, most of the work that needs to happen inside it is already done. Assembling the blocks requires a level of precision that is genuinely difficult to appreciate without standing next to it. The stern section of the ship, just the back end, is made from 5 blocks joined together and weighs 790 tons, the same as 2 railway locomotives. Moving it into position required 2 cranes working simultaneously, and once it is placed, the margin of error is 1 millimeter. A single millimeter of misalignment can compromise the structural integrity of the entire hull and undo months of work. When all the major blocks are in position, the welding begins. The total length of welding on a single ship is 1,250 kilometers. If you laid it in a straight line, it would stretch from Karachi to Lahore and back. Every single weld joint is then inspected individually because the ocean does not forgive weak points. Now we come to the part that makes this ship genuinely different from anything built before it, the LNG fuel system. Keeping LNG in liquid form requires maintaining a temperature of -163 degrees Celsius. That is colder than the surface of Mars. If the temperature inside the fuel tank rises even slightly, the LNG starts converting back to gas, and the system fails. The fuel tank on each of these ships is the largest LNG fuel tank ever installed on a cargo ship. Its internal volume is 18,000 cubic meters, large enough to fit 6 Olympic-sized swimming pools inside it. The total fuel capacity is approximately 20 million liters of LNG. Building a tank this large and keeping it at -163 degrees requires insulation technology that is normally found in one other context: the fuel systems of rockets at space launch facilities.
The tank walls are built up in multiple layers of insulating material, each one designed to slow the transfer of heat from the outside environment to the interior of the tank. Once the insulation is in place, every single joint in the tank structure must be tested for leaks. The method is elegantly simple. Workers apply soapy water to the joints, place a glass container over them, and use a compressor to pull a vacuum inside the container. If a joint is weak, the pressure difference will pull air through it, and bubbles will appear in the soapy water. Every leak point identified this way is repaired and retested. Once all joints pass, the final layer of insulation goes on, a membrane of stainless steel just 1.2 millimeters thick. This membrane is designed with a wave pattern pressed into it. When extremely cold LNG hits the steel contracts. The wave pattern allows the steel to shrink and expand without cracking, the same way an accordion expands and contracts without breaking. This membrane technology was originally developed for the aerospace industry and has been adapted here for marine use.
The engine that drives this ship is the largest natural gas-powered marine engine ever built. It is 20 meters tall, 6 stories, and weighs more than 2,000 tons. It produces 85,000 horsepower. It is so large that maintenance workers can physically walk inside it to service the components. Transporting this engine to the shipyard required cutting it into 6 separate sections and shipping them individually. The crankshaft alone, the shaft that transfers power from the pistons to the propeller, weighs 220 tons and required a remote-controlled platform with 140 wheels to move it through the shipyard. Installing it required millimeter-level precision alignment. Any deviation from perfectly straight would cause destructive vibration at operating speeds. The engine has 12 pistons, each one a meter in diameter. When all 12 fire in sequence, the crankshaft rotates and drives the propeller shaft, which runs the length of the ship to the propeller at the stern. The propeller itself is a single cast piece of metal, weighing 92 tons and standing 10 meters tall, as high as a 3-story building. It was cast in one piece because any joint in a propeller creates a potential stress.
After 18 months of construction, each completed ship undergoes 15 days of sea trials. The engine is run at full power. Emergency braking is tested. Stopping a fully loaded ship of this size takes several kilometers of ocean. The navigation systems are calibrated. The anchor system is deployed and retrieved. On a ship this size, a single link of the anchor chain weighs 300 kilograms, and the full anchor chain weighs as much as 60 African elephants. Every system on the ship is tested under real conditions before the vessel is certified for commercial operation. One by one, all 9 ships passed their sea trials. One by one, they left the shipyard in Hong Kong and entered commercial service. Each ship operating on LNG instead of conventional fuel prevents hundreds of thousands of tons of polluting emissions per year compared to a conventional vessel of the same size. Across all 9 ships, the environmental difference over a typical 25-year service life is enormous. 6,000 workers, 9 ships, 2 years, an engine you can walk inside, a fuel tank colder than Mars, a propeller taller than a house, and a weld line long enough to cross a country. This is what human engineering looks like when the goal is not just to build something big, but to build something better. Subscribe to RM Journal for the stories worth knowing.